This video is a part of my full digital guitar pedal building course. In this video, I'll teach you how to assign footprints and make a custom one for parts that we find online using a datasheet. By the end, we'll have made this custom footprint for this right-angled pot that we found on Tata Electronics. This course is also sponsored by PCB, a quick, cheap, and well-made solution for getting PCBs custom manufactured. I'll show you how to order through them later in the course, so stay tuned for that. So there's one last big thing that we have to do, not exactly on this circuit, but on all of our symbols to then prep our PCB. I mentioned this before, but these are called symbols, and then on the PCB we have what are called footprints. We need to have each symbol connected to a specific footprint, so once we go into the PCB designer, it will, for instance, know that this pot 1 is the specific 3-pin layout that we have for the specific knob that we are going to use and purchase. There are a lot of standard ones like your resistor and LED, but we will need to find or make ones like our knob. If we come up to the top menu, you will see this footprint editor here. You can click that and you will see all of the different footprints they have. They are sorted into all these different categories. So like a capacitor, and this THT means through hole, which is what we're going to be doing for this. The other option is SMD, surface mount device. You will typically see surface mount stuff in professional pedals or just all PCBs of all kind. But since this is something that is just like if you order for yourself and you want to solder, through hole is much easier to solder. And in the context of the pedal we're making, which is super minimal, we don't really have to fight for any space, so through hole is totally fine. Here you can click around and see all the different footprints, but I have been having this unfortunate glitch where it just doesn't show anything. I knew there was some way for me to get around this, but it should work for you, hopefully. And it doesn't matter a whole bunch at this moment because there is another way to view it. So if I close that and then come up to this symbol, this is where we can actually assign each symbol to a specific footprint. So like here we have this LED, and then on the left are all the different footprint libraries, so those just overall categories, and then we can come up here and filter it by specific things. So like this first one will let us filter it by the footprint filters defined in the symbol. So that is definitely a really handy one to do. So like if I had none on, you can see we just have every single footprint here. The default library with this version comes with 1180 footprints. And then we can also sort by pin count, which is handy. So the software knows that this LED is only 2 pins. So there's no reason for all of these ones with like a ton to pop up. So I just filtered by only ones with 2 pins, and then you can also hit here to filter by library, which then I can type that in right here. So I'm just going to filter by all of them, and then you can see here we have just a pretty small list of LEDs. The LED that I am going to be using, which is kind of the typical one you will get, has a diameter of about 5 millimeters. If you have any sort of basic kit, that's probably also what you have, but as always, make sure you check. But I'm just going to come here and make sure we are looking at the LED through hole, so the THT, and then you can see all of these different sort of measurements. They're a little annoying to read, but they are pretty self-explanatory. If you see D, that is the diameter. And then in this case, the horizontal is probably, yes, because this footprint is meant for having your LED that way. We're not going to have it like that, so I wouldn't worry about that. But right here, I already just see this D 5 millimeter. So I'm going to click that, and that looks exactly like what I want. So I can just double click that. And now that is assigned to the LED here. And also we can see that the Daisy already has assigned that one footprint to it, because the Daisy, obviously there's not all these different ways that you can pick from. So it already just assigned it. Now, in terms of our audio jack and DC jack and even the foot switch, all of those are going to be just hand soldered and wired into there. Unless you chose to do ones that are PCB mounted, then hopefully you can figure out how you're going to do that. But in my case, I just selected to do hand soldered ones just because it's a little bit easier to do the PCB design, and it honestly is higher quality because having PCB mounted components just give a lot of extra stress onto the PCB, and they're a lot harder to replace if something were to break, because obviously you can just unscrew and rewire a simple jack, but you would have to take out the entire PCB and desolder every single pin in order to replace a broken one that was soldered onto the PCB. But in order to get some connectors that we can just solder onto there, we are going to need to go to the connector library. So that is right here, and then I can hit connector, and we do actually want to hit the library on. So we're just on this connector here, and I can already see that this is not exactly what we want. These are sort of very strange connectors. So this is something where you can just look and be like, okay, that's not what I want. So we can go down and see that we have this connector wire, which is what we want because we're just trying to connect some wires. So now we have this very big list of all these different wires. So first thing we want is just to hit pin, so we can just only have everything with 2 pins here. And now we can read what this has to say. So like all footprints, there are all these different measurements here, but these are pretty self-explanatory. This first measurement is pretty much your wire gauge. This is in square millimeters. You can search any chart on this, but 0.5 square millimeters sits around your 20 gauge, which is pretty much around what typical wires that you will pick up for this sort of thing. So now we can just see all of these 0.5s here. So we're going to need one of these. So then this second one is just saying how many pins there are and how many rows there are. So this is 1 row of 2 pins. All of these are going to be 1 row of 2 pins since we sorted by pin. And then the next one is pitch, which is just the distance between each pins. Typically something like a proto board, which is all your pins and PCBs are designed with about 2.54 millimeters spacing. So that's just a good reference point. Something like this is a little bit bigger, which is just going to be like a little nicer to solder. So there's less chance of like solder bridges or something. And then right here, we have the diameter of the actual hole. And then we have the outer diameter, which factors in the size of the pad that we will be soldering on. Then you'll also see these ones with relief, and if I go and select these, you'll see that they have just this sort of long thing and then another hole, and this is basically just a way to make sure that your wires aren't putting too much strain on the actual joints if they're kind of being moved or stretched around. So it's a way to just kind of hide your wires and maybe route them through that or add little like zip ties. Sometimes people do, but we're not going to worry about that for now. So it's looking like with this gauge of wire, our 2 choices are pretty much just these 2, and you'll see this one just has a slightly larger pitch and a larger outer diameter, meaning the pads are just a little bit bigger. But I think that this first one here will be totally fine. So I can just double click that for this jack, and even the DC jack will also take that one, and our switch. So now we only have 4 things left. First, we can just deal with this resistor here. So once again, we can go and make sure we are sorting by the resistor library. So we can come down, find the resistor through hole, make sure your pin thing here is checked, and now we have all of these different resistors. Your typical resistors are those axial ones, so we'll want all of these here. So resistors, like everything, have their own sort of little codes. Your typical resistors are going to be the axial ones, so we can ignore these radial bucks and all of these other ones. And then you'll see these other little codes, and basically this stands for the overall diameter and length, just sort of roughly. So this DIN 0207 means it is roughly 2 millimeters in diameter and 7 millimeters in length. But then you can see this then classifies even deeper than that. So this one is for 6.3 millimeters and 2.5 in diameter, and then a pitch of 7.62. And then you can see they have vertical variations. So if you want your resistors to be kind of standing up like some people do, you can do that. But we're going to have just the horizontal sort of long ones. You're of course welcome to measure out the resistors you have and everything, but I happen to know that for the ones that I have, this footprint right here works out great, number 8. So now the only thing we have remaining are our 3 potentiometers. So you can see here when I sort and go into the potentiometer through hole, there are some that might work if you have them, but for the most part, especially if I go and look at the exact one we bought and see that the manufacturer is Tata Electronics themselves, we can probably assume that they do not have this on there. So there are a few things we can do when we see that KiCad does not have the footprint we want. The first one is to just find and search for this part number and see if anybody has done it online, or we can make our own. In the case of this knob, if you were to go and search it, you will find a few 3D models, but there is no specific footprint that pops up immediately because honestly, it is a pretty simple footprint that we can go and make ourselves. So I did realize the knob that I actually got was this 10K one by Alpha. Pretty much the same thing, but yeah, we can make this ourselves quite simply. I'll honestly probably go through it somewhat quick because there are many tutorials on how to do this also in KiCad, but make sure you get your data sheet up. You can see that this one, if you remember, the other one had a 16.5 difference between them, but the ones I have 16 millimeters between the center here and the pins, so that's definitely really good to know. And then we can go and kind of just read here. A lot of this we don't need, we really just want the distance between this hole and the pins, which we needed for making our drill schematic. And then the other main thing is just the size of these pins themselves, which this is that sort of mounting hole detail thing here. We can see all these circles, which are just pretty clearly this right here. We can see there's 5 millimeters between each one. That is something we'll need to know. And then it says there are 3 with a diameter of 1.2. These are all in millimeters. That's quite standard. So we just know that we need 1.2 millimeter holes. Typically, if something says mounting hole, then that means that that's the actual size of the hole that we will make. So we don't really have to add clearance on top of that. Typically, there might be exceptions to that. I've always found that what they say here is pretty much good. This is typically given for the point of making footprints and things. So yeah. All right, so I'm back here in KiCad and we need to make our footprints for this. So what we can do is come up here to the edit, delete, create, edit footprints. And then mine started working again. Suddenly I can click it, unlike earlier, but we can just come up to this top left thing here to hit a new footprint. You can name it probably just the part number. I think mine was the RV, 164A or something, RV16AF. Okay, so I'll just name it exactly that, just so we know. Or you could just say potentiometer, make sure to select through hole in the case of this, pot or SMD if it is, obviously. So there's a few things here. We haven't gone over what all of these layers are yet. We will get to that when we start our PCB. For now, we can somewhat ignore them. The main thing are pads. Those are going to be the actual pins that we will make and solder onto. And then there's a couple other things with the layers, but I'm going to have, right next to me, I have another monitor that has the mounting hole thing up. So definitely good to just have that referenced. And we are just going to place these pads. So you can see down here, we have coordinate points of everything. So these are your X and Y's. And then the DX, you can hit space and it'll zero out everything. So if I just want to make sure, I could just zero them out to be the same thing, but you can always have a nice reference point. So I'm just going to put this one directly at the center there. And then from looking at this chart, we know that these should all be spaced 5 apart. So what I can do is just select this pad and I can just duplicate it, place it in the same thing, and then select that one. And we can do positioning tools, move exactly. And I can just say -5, and then that'll place that there. I can do the same thing again. We can duplicate it or hit Command D, place it, and then position tools. And this time we want to put it at 5. So now they're spaced, but obviously they all say 1, and we haven't actually looked at the holes yet. These reference things, you'll see they just show up and say certain little values that we can set and everything. But we need these numbers here to match the actual numbers in our schematic. So if we go down here, we can see there's this 1, 2, and 3. And so this is our way for our footprint to connect up to our symbols to make sure that the right pins are connected. So it's very, very important that you get this right. Sometimes they won't be numbers, they'll be letters like this S and T. So if you had a footprint that did not have S and T, but the symbol did, that'll cause some issues, which we might run into later. So we just know that we want the 1 to be the one that goes to the 3v3 and the 3 to be the ground. That doesn't matter too much because we just know that the center one we need to be 2. So we can say 2 here, and then we can say 3 there. Where this does matter though is when it comes to sizing. A lot of times you'll see ground pins are square or rectangular pads instead of these circles. So that can be a nice thing to add. So here we can just come into 3 and make this rectangular. So now it looks like that. And then we can go through and we need to make sure that it is a 1.2 diameter. So you'll see 2 different values here. There's the hole shape and then the pad shape. The hole shape is that actual kind of inner diameter of the drilled out one. So that's what we want to make 1.2. And the pad shape is going to be after this outer diameter. So you can take this pad shape minus the hole shape diameter, and that'll give you just the length of this right here. Take that divided by 2, and that'll be each one of these. And typically I like to just add pretty much a millimeter on top of that. So here we can make it 2 by 2 or 2.2. That's being pretty generous. You could even throw that to 2. So this will just be the amount of space on each pad that we have to solder. So this will work totally fine. You don't want this too thin, and then you don't really need it too big. If something is like this pot where we're mounting it, then bigger can be better. So we just get a really secure solder joint on there. But yeah, that should be good for that. And then we just want to do the same. Guess you probably should have done this before duplicating it, but this works fine. So then come in here, and then the same thing with the X and Y will just set to the same values. So it is a square. And that's really it for this. So this will work totally fine. But we can do a few more things. One is that we want to give some sort of indication on the PCB that these are one component. So one way we can do that is with this silkscreen layer. As I'll explain later, the silkscreen is where we can put graphics and things like you can see on this PCB. Basically everything that isn't the pads, like this white circle there and my name down there, that's all on the silkscreen layer. So we just want to sort of put a little rectangle to group these things. It really doesn't matter a whole bunch. So I can just do that, and that's probably good. You could have it be nicer if you can do a Command-Shift-M or hit this measurement tool down there to kind of measure the distance between things. So if you want to get them exact, you can totally do that. But another thing to add is this courtyard. A courtyard layer, basically, it doesn't print anything, but it will make it so that your parts can't overlap when the courtyards are touching. So if I put a courtyard to be pretty much the exact same thing as this one, then that means, here, let me move that down. So that means that something couldn't be placed to overlap with these two courtyards. So say I had two of these pots, obviously the pads couldn't be directly overlapping, but now there's this extra little leeway space, which is probably good to put with the actual pot, the circle itself, which is something else we can put. So here, as you can see, we have that 16 millimeters between the center of the pot and the pins. And so it would be nice to kind of just show a little indication in the software of which way this pot is oriented. And it can be a little strange to think about as first. We can select our silkscreen. But if you'll remember the PCB I showed you earlier, we have all the stuff soldered on one side, and then the pots are actually the opposite side of that. So like with this PCB here, let me switch the screen. With this PCB here, everything is soldered on this top. So this is actually the front, or that F layer, as you can see in here, and then this is the bottom layer. But the thing is, you can solder on either side with these through-hole components. So this is just a random PCB. This is the one that we're actually making. But I made this and all the other ones so that the pots are below like this, which means that if this is the front, that the pot is actually on top of these pins right here. It's kind of confusing to think about, but basically we just want to make sure that we place this diameter circle above these pins. So as we can see, this says 16.5 diameter. There is this one that says 17 over here. We can just go with this 16.5. So if I want to select this circle tool, make sure I have the front silkscreen layer selected, and I'll do that same little thing where we can create this in the center. I'll set it to any radius for now. If you just click and then go back to this tool or hit escape, and then I can hit E on the circle and then select our radius. So we want half of the 16.5, so that would be 8.25. Select that, and then we can do the same move exactly. In this case, we want to go up, which is actually negative Y, so I can do negative 16, and it places it right above it. So that's pretty much everything we need. You could add the courtyard so it extends out, but the thing with that is, well, two pots couldn't be next to each other that close because of this whole pot size. Other parts could totally fine sit there, so this is something that I would just pay attention to, and that's why we make this whole graphic, is so that if you were to put two pots way too close to each other, and with the drill tool it was totally fine, and then with the pins it's totally fine, but now we would be able to see those overlap, and we know that we should not put them that way. But besides that, this totally works great. So I can hit save. We could maybe just put potentiometer in front of this and then put an underscore, because that has how they name their own. And you could make your own library, or you could just add it to their potentiometer underscore THT. So there we go, and I can just hit OK. So now coming back into the schematic, we just want to hit our assign schematic tool, select potentiometer. We want to find the library for it right there. Probably scroll down, here it is, RV16AF, and now I can just select that for all three of those, hit apply, and we are done. So it's pretty simple for this circuit, but obviously you can maybe imagine that that part can get very complex because you need to really cross-check all your parts, all your dimensions. But For us, it was pretty simple, and now we can move on to the PCB. Wasn't that just so much fun? Hopefully by now you know how to make, create, and assign your own custom footprints or the ones in the KiCad library, so going forth we can actually start placing all of our parts on the PCB and routing them. The playlist for the full build is linked below. I'll see you there.